In 7.4, we're moving away from hypothesis testing for means, and we're going to use hypothesis testing for proportions. We did confidence intervals for proportions, and we're using the same types of calculations for hypothesis testing, except that we need to use a significance level. Remember that if you don't know the proportion, your p hat is equal to the number in your sample that have that attribute divided by the total number in your sample. So you can always find your proportion for your sample. In order to check the conditions, you need to make sure that not only is it approximated by a normal distribution, but that it's random and that NP and NQ both are greater than or equal to 5. You're going to state your null and alternate hypothesis just like you did for the means. You're going to have an alpha level. Your z-score is found by using this equation, just like before, where the standard error is found by taking the square root of p times q divided by n. But otherwise, you do the steps exactly the same way, except we're using a proportion instead of a mean. Here, a researcher claims that less than 45% of U.S. adults use passwords that are less secure because complicated ones are too hard to remember. So he sampled 100 adults, of which 41% say they use passwords that are less secure because they're too hard to remember. We're going to use an alpha level of 0.01, and we have to decide if there is enough evidence to support this researcher's claim. So here our n is 100. Our probability of success, our p, is equal to 45%, so 0.45. That means our q is 0.55. Our p hat, our proportion from our sample, is 0.41. Our alpha level is 0.01. And we need to find a null hypothesis and an alternate hypothesis. We are supposed to decide if we can support the researcher's claim that he thinks less than 45% of US adults use passwords that are less secure because complicated ones are too hard to remember. So he's saying that the proportion that use less secure passwords is less than 0.45. So the null hypothesis would be p is greater than or equal to 0.45. That means this is a left-tailed test from this right here. So we're going to start with our standard error equation, which is the square root of our p, which is 0.45, times our q, which is 0.55, divided by the square root of n, which is 1, or divided by n. The standard error is going to be 0.0497493719. From that, we can find our z-score, which is going to be our sample p, which is 0.41, minus our population proportion, 0.45, divided by 0.0497, which gives us a z-score of negative 0.80403.02522. Now we need to find our p-value that goes along with that. Since this is a normal model, we can use normal CDF of negative 200 to that number, which gives us a p-value of 0.2106896879. Remember, our alpha level is 0.01 and our p-value is greater than our alpha. That means we fail to reject. That means we cannot support the claim. So with a p-value of 0.2107, we fail to reject the null hypothesis. There is not enough evidence to support the claim that the proportion of U.S. adults who use less secure passwords is less than 0.45. And this type of test can be done on the calculator also. So this is a new type of test. This is, you get to it using the stat button again. You have to go to tests. But since this is a test for proportions, you have to do one proportion z-test, one proportion z-test. And the parameters that you're going to put in using the stats is that P naught, that's your population proportion, 0.45. Your X has to be the number of people out of all of the people that are in the sample. So that's going to be 0.41 times n, which is 100. So 41. That must be a whole number. And then n is going to be 100. And then you have to decide which type of test it's going to be. And since this is a left test, it's going to be less than P naught.